Hello students, welcome to Stuti Academy. In this video, I'll explain is matter around us pure chapter, which is chapter number 2 of chemistry, class 9. In chapter 1 video, I explain what is matter, what are its properties. In this video, I'll tell you about types of matter which are present in the nature. We'll broadly classified matter into two main categories, that is pure substances and impure substances. Impure substances, we also call them mixture. First of all, we'll talk about pure substances. As you can see in this flow chart, pure substances is further divided into elements and compounds. And impure substances are of two types, homogeneous and heterogeneous. We'll study about these pure and impure substances in detail in this chapter. First, let's take elements. Elements are the purest form of the substances. And why we call them pure substances, or why we call them the purest form of the substances? Because they are made up of only one type of the substance. For example, if we are talking about copper, copper itself is made up of n number of atoms of copper only. Similarly with the aluminium, aluminium is made up of only atoms of aluminium. That is why it falls under the category of pure substances. And these elements cannot be broken down into simpler form by physical means or any chemical method. They can be separated only by some nuclear reactions only. On the other hand, another form of pure substances is compounds. Compounds also come under the category of pure substances, although they are made up of one or more elements. When one or more elements combine together in a fixed composition, in a fixed ratio, then they form compounds. For example, H2O. The formula of water is H2O. It means there is a fixed composition or fixed ratio of water in it. And these compounds can be separated by chemical methods or electrochemical methods. Then we have impure substances, or we call them mixtures as well. They are of two types, homogeneous and heterogeneous. Homogeneous means uniform composition. Uniform composition here means when we are mixing two or more substances together. They are made up of when two or more compounds combine together, then they form mixture. If they are mixed together and there is a uniformity in the mixture. Uniformity means if we cannot separate the boundaries of the two substances in a mixture, then it falls under the category of homogeneous mixture. Heterogeneous mixtures are the non-uniform, in which we can easily separate the boundaries of two substances which present in the mixture. Example of homogeneous mixtures are, if we mix sugar and water, salt and water, after stirring sugar into water, we cannot differentiate where the sugar is present and where is the water. Similarly with water and alcohol, once we mix this, we cannot separate the boundary. On the contrary, if we take a mixture of sand and sugar, it is very easy for us to distinguish between them because of their size particles. And if we are talking about water and oil, we can easily see the boundary of oil that is separated from the water. It keeps floating on it. These are the various forms of the matter. We'll study these forms in detail one by one. And on the basis of this, what type of question comes in the exam? Here classify brass and diamond as element and mixture. Brass, as we know, it is a homogeneous mixture. It is an alloy. Alloys are those substances which are made by the combination of two or more metals. So it is the combination of two or more metals, but they are homogeneous mixture. So brass is a homogeneous mixture. Diamond is a form of, it is an allotrope of carbon. So it comes under the category of element because it is made up of carbon atoms only. First we'll study about elements. Elements are the pure substances which are made up of only one type of the substance, and we cannot separate them by any physical or chemical means. Elements are further classified into 2 or 3 categories mainly: metals, non-metals and metalloid. First of all, metals. Metals are malleable, which means they can be converted into thin sheets. For example, aluminium, copper, gold. We can easily convert them into thin sheets. We use aluminium foil in our kitchen for packaging of food material. So this can be converted into sheet, that is aluminium, which is a metal. Metals can easily be drawn into wires, which is the property known as ductile or ductility. Aluminium, copper, gold, silver, these metals can be easily converted into wire form. Metals considered to be the good conductor of heat and electricity. So these are the properties of metals, and the examples of metals are copper, gold, aluminium, iron. These are the examples of metal. Non-metals are having property exactly opposite to those of metal. They are non-malleable. We cannot convert them into sheet like oxygen, nitrogen, sulfur. They are non-ductile. We cannot convert them into wires as well. And they are considered to be bad conductors of heat. Examples of non-metals: sulfur, oxygen, nitrogen. These are the examples. But there are some exceptions in metals and non-metals. In metals, sodium and potassium are the exceptions, which are very soft. They can easily cut with the knife. Other metals are very hard. We cannot cut them with a knife. And if we are talking about non-metals, exception in the non-metal: diamond, graphite, which is the allotrope of carbon. So we can say that carbon is a good conductor of electricity because we use graphite in our machines also. It is a good conductor of electricity. So there are some exceptions in metals and in non-metal. Now third category is metalloids. Metalloids are those substances which have the properties of both metals as well as non-metal. And examples of those metalloids are silicon, boron, arsenic. These are the metalloids. And they all fall under the category of elements only because they are made up of only one type of the substance. Now, what type of question comes from this topic? And the question is how metals are different from non-metals, or write the difference between metals and non-metals. So these are the points. First is metals are malleable and ductile. Non-metals are brittle. They are neither malleable nor ductile. We can break them very easily. Metals are good conductor of electricity and heat. Non-metals are bad conductor of heat and electricity, except graphite, which is a allotrope of carbon. Metals are lustrous and can be polished. Lustrous means they have shine. Like if we are talking about gold, silver, they are quite shiny in nature. Non-metals do not have any shine and we cannot polish them except for iodine. Metals are solid at room temperature. Only exception with the mercury, which is liquid at room temperature. That is the reason why we use mercury in thermometer. And non-metals, they may be solid, liquid or gases at room temperature. Metals are strong and tough. Non-metals are not strong or tough. We can easily break them. Now, second category of pure substances is compounds. Compounds are also the purest form of substances, but they are made up of 2 or more elements and they are chemically combined together, but in a definite ratio, in a definite mass. And what are the characteristics of compounds, or what are the examples of compounds? Water, carbon dioxide, these are the examples of the compound. And they have a fixed melting and boiling point. They are homogeneous substance. Homogeneous substance means once they mix together, then they mingle up together in such a way that we cannot differentiate different elements which are present in them. And they can be separated by chemical processes or by passing electricity or electrochemical. Now, the question comes from this topic is, what are compounds? List some of its characteristics. So, in this question, we have to write the definition of compounds, that they are pure substances which are made up of two or more elements and they are chemically combined in a unit ratio. The characteristics of compounds are, they have a different constituents. The properties of compound differ from those of its constituent, which means if we mix elements in it, the properties of elements are entirely different from those of the product which is formed after combining. Then compounds have a fixed melting and boiling point. They have fixed melting and boiling point. They are homogeneous substance and they can be separated by chemical process. One very important point to be remembered in this, that when you make a compound, the properties of that compound is entirely different from that of the substance which we used in its making. For example, hydrogen and oxygen, we combine them to make water. The property of hydrogen and oxygen is entirely different. So, when we take water, its property is entirely different from that of the hydrogen and oxygen. Now come mixtures. Mixtures are made up of two or more elements or compounds and they are mixed in any ratio or proportion. Their ratio is not fixed. They may be homogeneous or heterogeneous. Homogeneous when there is a uniformity in their composition, and heterogeneous when there is non-uniformity in their composition. And in mixtures, the properties of the constituents are retained. It means the substances which are present in the mixtures, they will not lose their property. Their property remains intact. No new compound is formed, only new substance is formed. And elements can be separated by simple physical processes. In mixtures, whatever elements are present, they can be separated by physical processes. For example, if we take a mixture of sand and rocks or sand or iron fillings, we can easily separate them by physical processes. And they do not have fixed melting and boiling point, because the compounds or the elements which are present in them, they have different melting and boiling point. And once they mix together, then their ratio also, their melting and boiling point also differ. Now, question comes from this mixture topic is, define mixtures and list some characteristics of it. So, in this question we have to write definition of mixture, that mixtures are those substances which are made up of two or more elements or compounds which are mixed in any ratio or proportion. And their characteristics are, they may be homogeneous or heterogeneous. Properties of the constituents are retained. No new compound is formed. Elements which are present in mixture can be separated by physical processes, and mixture do not have any fixed melting and boiling. Another question asked in CBSE in 2010 and 2011. It's very important question. Water is a compound and not a mixture. Justify the statement giving two reasons. As we know that the formula of water is H2O. It means two elements are present in water, that is hydrogen and oxygen, and they both combine chemically, which boils at a fixed temperature. Then next statement for justification of this answer is the properties of water are different from that of the hydrogen and oxygen. For example, hydrogen is combustible substance. Oxygen is a supporter of combustion. It helps in in the fire. Then water helps to extinguish that fire. So the properties of the mixture which is formed after the combination of hydrogen and oxygen are entirely different. Now there are two types of changes, physical and chemical changes. They are different from each other. If we are talking about physical changes are those changes in which no new substance is formed. Only there is a change in the state, color, shape and size. In chemical change, new substances are formed. For example, if we tear a paper, only we are changing the shape of the size of the paper, but the paper remains as it is. There is no formation of any new substance. But if we are talking about chemical change, for example, if iron gets rusted due to the presence of oxygen and hydrogen, iron oxide is formed, which is entirely a new substance. And the properties of iron oxide is entirely different from that of the iron and oxygen. In physical changes, the properties of the substances remains retained. They will not change. For example, if we mix salt and water, it's a physical change. It makes lemonade, but the properties of the salt and the water remains there. But in chemical change, as I told you, if iron comes in contact with oxygen and water, it's entirely changed. In physical changes does not involve the loss or gain of heat. There is no loss or gain of heat takes place. But in chemical changes, there is either the loss of heat or the gain of heat. In physical changes, they are reversible. Chemical changes are irreversible. If we tear the page, we can make the paper again. And melting of wax is also a physical change. We solidified it, then again we get the wax again. So that is a physical change. But heating of a candle is the chemical change. If we burn the candle, it produces heat and light. So that is a chemical change. New substances. Ripening of fruit is a chemical change. Growing of a human being is a chemical change. Digestion of food in our body is a chemical. How is the chemical change different from a physical change? This type of question asked from the topic, and in a chemical you can write any of the difference which I have just discussed with you. One such point is, in a chemical change new substance is formed, while in a physical change no new substances. Apart from this point, you can write any other point from this table. Now next is solution. Solutions are also known as homogeneous mixtures. And these homogeneous mixtures are made up of two or more substances. And the substances which are present in, we call them solute or solvent. For example, if we are talking about solute or solvent, suppose here is a mixture in which water is present. This is water, and if I add sugar into it, this liquid substance is known as solvent, and this is known as solute. So solute is that substance which is dissolved in a solvent, and solvent is that liquid part of the solution in which we dissolve solute. And this solute can be solid, liquid or gas, and solvent can also be solved. Yeah. There are certain types of solution. Different types of solution have aqueous solution, non-aqueous solution, true solution, saturated solution, unsaturated solution, and dilute or concentrate. First is aqueous solution. Aqueous solution is that type of solution in which water acts as a solvent and we can add any solute into it. But here water is a medium of solvent and that kind of solution is known as aqueous solution. Then next is non-aqueous solution. Non-aqueous solution is that kind of in which apart from water, other substances act like a solvent. For example, like carbon disulfide, iodine, these act like a solvent. And when iodine is a solvent, we call it tincture of iodine. Tincture of iodine. And iodine is a solvent. Then we have true solution. True solutions are those solutions which solute particles are completely dissolved in solvent. For example, sugar and water, mixture of salt and water. So once we mix them together, we cannot separate them or we cannot see their boundaries once they are mixed together. The size of the particles of true solution are very small. Then we have saturated solution. Saturated solutions are those solutions in which no more solute can be added. If we have beaker in which water is present, which is a solvent, and if I add sugar into it, which act like a solute. And as we know, in liquid, the particles are far away from each other. They have certain spaces between. When we add solute into it, these spaces are taken up by solute particles. Once all the spaces are taken up by solute particles and then they mix together, and if there is no space left behind, so we cannot add more solute, then it becomes a saturated solution. An unsaturated solution is that solution in which we can add more solute, means still spaces are left behind a solvent. So these kind of solutions as unsaturated solution. Then this saturated solution can easily be converted into unsaturated solution under one condition, and that condition is by increasing temperature. If we increase the temperature, the liquid particle, the particles of liquid substance, of solvent, they start gaining energy and the particle starts vibrating and start leaving some spaces between them. They start creating more space between, and in that case, in that condition, you can add more solute in. So under this condition, the saturated solution becomes unsaturated. So we can say that we can easily convert saturated solution to unsaturated solution by increasing temperature. Another two type of solutions are dilute and concentrated solutions. Dilute solutions are those solutions in which maximum amount of water is present in a solution. It means 90% water is present and only 10% solute is present. And in concentrated, it is just opposite. Here 90% solute is present and only 10% solvent is present. For example, we have HCl, that is hydrochloric acid. It exists in two forms, dilute and concentrated HCl. We read like this, or we can write dilute like this and concentrated like this. Here it means in this dilute HCl, 90% of the water is present and only 10% acid is present. Means 90% water and 10% acid. While in concentrated, 90% acid, 10% water is. Now, there are certain formulas to find out the concentration of the solution or mass of the solution or by volume or percentage of the solution. So, if we need to find out the concentration of solution, we have to use this formula: amount of solute or amount of solution, or amount of solute or amount of solvent multiplied by 100. It depends on the question, what is given in the question. If the solute and solution are given, formula, solute and solvent are given, use this formula. If we need to find out the mass by mass percentage, we use this formula: mass of solute upon mass of solution multiplied by 100. And if we want to find out mass by volume percentage of a solution, then we use this formula: of solute, volume of solution multiplied by 100. Now, there are certain questions based on these formulas which ask in exam so many times. Question number 1 is: 100 gram of a solute are present in 500 gram of. Calculate the concentration of solution. Here, mass of solute is given, which is 100 gram, and mass of solution is given, which is 550 gram. We need to find out the concentration of the solution. So, for this, we use this formula: mass of solute upon mass of solution multiplied by 100. Just after putting the values of solute, which is 100 gram and 550 gram mass of solution, when we multiply with 100, we get this 1, 5, then 20. We will get 20% concentration in solution. Now, question number 2. To make a saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water at 293. Find the concentration in terms of mass of solution at this temperature. So, here we need to find out the concentration in terms of mass of solution. So, first of all, we need to understand what this question. To make a saturated solution, we need 36 gram of sodium chloride. This sodium chloride is a solute here, is dissolved in 100 gram of water, and this water is solvent here. Find the concentration in terms of mass of solution. We need to find out the mass of the solution when they both mix together. Mass of solute is given 36 and mass of solvent is given 100. And when we combine them together, when we add them together, 136 of solution is prepared after adding solute and solvent. Next question is: a solute contains 50 gram of sugar in 450 gram of water. calculate the concentration in terms of mass by mass percentage. You see, mass by mass percentage of. So it means solution contains 50 gram of sugar. Here, sugar is a solute and it is 50 gram in 450 gram of water, and the solvent is 450 gram. Calculate the concentration in term of mass by mass percentage of solution. So we need to find out mass by mass percentage. Here it means we have to find out the mass of both the components which are present in this solution, and the two components are present, sugar and water. We need to find out their masses. How can we find out mass percentage? We need to find out. So how will we find out? The formula is mass percentage of sugar. Mass of sugar is already given, which is 50 gram, and formula for this is mass of solution. How it becomes a solution? When we add solute and solvent together, 450 plus 50 becomes 500. Means mass of the solution is 500, which is written here. Multiply by 100, and if solve it, then we'll get this answer. This is 10%. Mass percentage of sugar is 10%, and mass of water is, if we know the mass of one substance or one component, we can easily find out the other one, because mass percentage of sugar is 10%, and by subtracting with 100 get 90%. So in this manner we can easily find out the mass percentage of sugar and mass percentage of water. Now other two types of solutions are suspension and colloidal solution. In suspension, the size of particles, solute particles, are quite big and they are clearly visible. For example, mixture of sand and water. Sand particles are easily visible in the water, and this being heavier in weight, they settle at the bottom. And due to the large size particles, they show Tyndall effect. Tyndall effect is the scattering of the light through the solution, through the particles of the solution. So being the bigger in size, they show the Tyndall effect, and they are translucent, or sometimes they are opaque also. Colloidal solutions are those in which the size of solute particles are not visible with the naked eye, and they also show Tyndall effect. They are translucent, and colloidal particles do not settle down, they remain suspended in the liquid. And the example of colloidal solution is like starch in water, blood, these, and milk and cream. They are the examples of colloidal solution. Now these are the properties of three main types of solution: suspension, colloidal, this is true solution. If we are talking about their particle size, suspensions have the bigger size than colloidal, and the minimum size of the particles are present in true solution. That is why they are homogeneous. Suspension cannot pass through the filter paper. Being bigger in size, the solute particles cannot pass through the filter paper. Colloidal particles can pass through filter paper but not through the membrane. Then like blood can easily pass through the membranes of the organelles present in the cells. Then solutions, they can easily pass through filter paper, like salt solution, sugar solution. Now settling of particles, as I told you, in suspension the particle size are quite bigger, so that is why they settle at the bottom. Colloidal, they will not settle, they will remain suspended, and in true solution also they will not settle at all. Then suspensions are opaque or somewhat translucent, but generally they are opaque. Colloidals are transparent and true solutions are transparent. And colloidal solutions are, we call them translucent also. Then Tyndall effect, suspensions show Tyndall effect, they allow the light to scatter, to pass through them or scatter through them. Colloidal particles also show Tyndall effect, solutions do not show Tyndall effect. In suspension, the particles do not diffuse because particle size are quite bigger. Colloidal particles, they diffuse slowly but not completely, and in solution they diffuse rapidly. The diffusion rate is fastest in the solution. Suspensions, they may show Brownian movement, colloidal show Brownian movement, and true solution may or may not show. Brownian movement is the movement of particles in a zigzag path. They are moving randomly. And suspensions are heterogeneous, they cannot mix together. Colloidals are heterogeneous and true solutions are completely homogeneous. Tyndall effect is the scattering of light by the particles in a colloid or some other solution. And the example of this is like canopy. In a dense forest, the trees are quite big, they are very tall. In dense forest, they are very tall and they like this. They are very close to each other. Very minute spaces are present between their leaves, which allow the scattering of the light through them, and this is known as Tyndall. Now, what type of question comes from this topic? This is like, what is Tyndall effect? Name two mixtures which show this effect. Tyndall effect is the scattering of beam of light by the dispersed phase particle in a colloidal solution when it is passing. Colloidal solution of dust particles suspended in air in a room, when light can enter through some hole, we can easily see the suspended particles, that light. And colloidal solution of starch in water. Next question is, state which of the following solutions exhibit Tyndall effect: starch solution, sodium chloride, or tincture of iodine. Tyndall effect is shown by starch solution here, which are heterogeneous mixture and have the capacity to scatter beam of light. As I told you, for the Tyndall effect, the size particle should be quite bigger so that it allow the light to pass through. While in sodium chloride and tincture of iodine, they both are homogeneous mixture. The size of the particles are very small, that is why they do not allow the light to pass through. That is the reason why they do not exhibit or do not show Tyndall effect. Now, in colloidal solution, two phases are there: dispersed phase and dispersing medium. Dispersed phase is that phase which is solute-like component. As we know, solution is made up of two things, solute and solvent. So, solute particle which are present in the colloidal solution, call it dispersed phase, and dispersing medium which these solute particles are present, call it dispersing medium. Like starch in water. So, starch in water, so starch is a dispersed phase and medium is water is a dispersing medium. Depending upon the dispersing phase and dispersing medium, colloidal part solutions are of different types. It is very important table. If the dispersing medium is liquid and dispersing phase is liquid and dispersing medium is gas, this type of colloid is known as aerosol, and example is fog, clouds and mist. Next is If dispersed phase is solid, medium is gas, the type of colloid is again aerosol. The examples are smoke, mobile and exhaust. If dispersed phase is gas, medium is liquid and the type of the colloid is, we call it foam. The example is shaving. If the dispersed phase with dispersing medium is also liquid, we call it emulsion type of colloid and the examples are milk and face cream. If dispersed phase is solid, dispersing medium liquid, we call it solution and the example is milk of magnesia and mud. If dispersed phase is gas, dispersing medium solid, we call it foam again. Examples are sponge or pure. If dispersed phase with dispersing medium solid, the type of the colloid is gel. The examples are jelly, is butter. Dispersed phase is liquid and dispersing medium also solid. Then we call it solid soul. The examples are gemstones and milky. Now these are the properties of suspension, colloid and true solution on the basis of the properties which I have already discussed with you. We are talking about particle size. If we are talking about filtration, how they settle at the bottom, appearance, their Tyndall effect, fusion of particles, Brownian movement, and what type of nature. So we classify these three into these main categories. Now the question comes on the basis of their properties is list any three differences between two solutions, colloidal and suspension. So this type of we can write any three properties, and if the question demands write 4 properties, 5 properties, then we can write any of the properties out of this very important question and frequently asked question. Next is on dissolving chalk powder in water, a suspension is obtained. Give any 4 reasons to support the fact that mixture so suspension only. Means how can we say that when we dissolve chalk powder in water, the suspension solution? So it means in this kind of question, we need to write the properties of suspension. And what are those properties? Chalk particles, a chalk powder can be easily seen with the naked eye. The particles can be separated by filter paper. Upon shaking, a white turgidity reappears in solution. It means when we shake them together, once the chalk particles settle at the bottom and when we mix them together, again the chalk particles comes up and they start rotating or they remain present in the solution. Light can pass through this suspension, which shows cannot pass through it, which shows that it is an opaque matter. Now there are certain techniques with the help of which you can easily separate the mixtures or the components present in the mixture. And these mixtures are of different types. Combination of two solids, combination of a solid liquid mixture type, combination of two liquids. Depending upon the type of mixture, we use different techniques. If a mixture is a combination of two solids, we can separate the components by physical means. Like if we take a mixture of iron filling, sulfur powder, or iron filling and sand, we can easily separate them by using magnet, because iron has a tendency to attract to the magnet, and we can, when we pass the magnet through that mixture, the iron particles stick to the magnet, and the other substance, whether it is a sulfur powder or the sand particles, they remain left behind. Or by using suitable solvent, if a mixture of sugar and sand are there, so we can easily separate them by sieving. Sugar are quite bigger, the size of the sugar particles are quite bigger, so they left behind, the sand can pass through. Ammonium chloride and common salt by sublimation process. First is by physical method. It depends on the size of the particles or the constituents present in a mixture. If the size of the particles of the components present in a mixture are big, so we can easily separate them by hand picking. For example, in our home, our mother preparing food for us. So before preparing rice or pulses, take out that mixture in a plate, and from that mixture can easily separate out if some small stones or some other undesirable components are present in rice or pulses. This method is known as hand picking. Next is sieving method. When we sieve flour, and or in people have seen laborers when they are doing work near the construction site, they can separate the rock particles from the cement through this sieving method. Next method is sublimation. Here, sublimation method is that method or process which solid can be converted directly into gaseous without going through the liquid. For example, naphthalene balls, then camphor. We use naphthalene balls to protect our clothes from the insects, and these are white color small balls. When we keep them, after a certain period of the time, the size of the balls reduce, so that solid directly converts into gaseous form without going through the liquid phase. Here is an example which ammonium chloride salt is present in this conical flask or inverted funnel, and cotton plug is there that it does not allow the air to enter into it. When we heat this ammonium chloride salt, then what will happen? See, the vapors of the ammonium chloride salt starts coming up. The moisture which is present in the ammonium chloride salt starts moving up and starts accumulating on the sides of the funnel. It becomes solidified. So here ammonium salt directly changes into vapors form without going through liquid phase. Means no liquid phase is, and this way we'll get the pure ammonium, because in this ammonium chloride salt some amount of water content is also present. So we are separating this salt from the water, and water, then this ammonium chloride starts evaporating and it goes, and the water vapors accumulate in this cotton. If we have a mixture of solid and liquid, then what type of techniques use? Filtration, purification, evaporation, crystallization, chromatography, distillation, or centrifugation. Generally, we use this for separating the cream from milk. First is filtration. In this process or in this method, the suspended particle, the size of the solute particles being heavier. So first we separate them, we mix them together, we mix solute and solvent together in a beaker. Here we use muddy water, which contains some sand particles and water. And then by using filter paper, use another task here. And if we pour this muddy water from here in this filter paper, mud, which contains very minute particles, but they are more bigger than the water, and it remains there in the filter paper, and the water gets collected in this conical flask, and the substance which is left behind the filter paper known as residue, and the liquid part which comes and collected in the conical flask as filtrate. Now, what type of question are? The question is, you are given a mixture of sand, water and mustard oil. How will you separate the components of this mixture? Explain with the help of different separation. So, first we will take this mixture. Then we pass through a glass funnel. Water and mustard will be collected in this filtrate, and the water, and this is the filter paper. This is filter paper. Sand is collected in this filter paper, and the water and the oil gets collected in this filtrate. So, and in this we will get oil here which starts floating on the water, and water is present. So, in this manner, you can easily separate the mixture of sand, mustard oil and water, because oil cannot get dissolved into water. It makes a separate layer. So, but they can easily pass through the filter paper, oil and water both. When they pass through it, they get collected in this conical flask, and being more denser than water, it keeps floating in the filtrate form, this conical flask. So, we can easily get the picture separated, and this sand is it or gets collected in the filter paper, and we call it this. Next method is evaporation. Evaporation is a process in which water changes into water vapor, or any liquid substance changes to gaseous. That is known as evaporation, and it can be separated by the volatile, used to separate the volatile component from the non-volatile. And the example of this is like if we have mixture of ink and water, when we mix them together, try to heat it. When we heat this, the water starts evaporating atmosphere form of water vapors, and the ink, which is the solute, it gets collected in this watch glass. Another example of this is we have a mixture of salt and water. So, in this also, if we heat the mixture, water gets evaporated and the salt is left behind, but still it contains some amount of water. Then we have centrifugation. But before centrifugation, I would like to tell you one more thing. We are trying to separate salt and water. We use this evaporation also, but if we want the purest form of salt, we use one more technique that I will discuss later. Then we have centrifugation. In centrifugation, we may separate the two liquids in a mixture, and these two liquids, when they mix together, we use this centrifuge machine, which on axis is present, and when we mix this liquid or the two liquids together or this mixture together, then the denser component starts migrating away from the axis. This is the axis, and then the lighter component migrate towards the axis. It means it comes up. The lighter one comes up and the heavier ones goes down. And this type of technique we use to separate stream from. The next method is chromatograph. This method is used to different components in a liquid mixture, and it depends on the solubility of the mixture. More soluble, it will move faster. Less soluble, it will move later. For example, we have this chromatograph paper, and when we have a mixture of different inks, so we put this spot on this chromatograph paper, dip the end of the chromatograph paper in a water. Just dip only the ends of the chromatograph paper, and when we dip it, then we observe that different components present in this ink, they start coming up. More soluble substance or the component move faster and it reaches at highest position. Then less soluble and the least soluble means at the lowest position. And what type of question asked in exam? And the question, what is chromatography? Write its two applications. In this chromatography technique, we separate different components from pigments or the dyes, and it has wide range of applications. Like we use for this in laboratories, for detecting the drugs in the blood. So these are the applications which use by the use of chromatography. If we need to separate the two immiscible liquids, how can we separate them? That can be done by separating funnel. Two immiscible liquids, the liquids which cannot mix together, they form separate layer. For example, if we need to separate the layer of oil and water or extraction of iron from its ore, we have this funnel which one stopper is present. Have one beaker here. If we pour the solution of suppose oil and water in, as we know, the stand it stand. Okay. Now, if we take a mixture of oil and water, we mix them together, pour the solution in this funnel. This is known as separating funnel. And oil being more denser, it starts collecting here, it makes a separate layer, and once makes the separate layer, then we turn on this nozzle and the water starts coming here in this beaker, and once the water comes here, the entire water comes here, we turn off this and then we get a separate layer. Beaker. The next technique is distillation. Distillation method we use for the components of the liquid mixture, and we use this technique for those liquids, for those mixtures in which have a difference of their boiling points more than 25 Kelvin. If the difference in the boiling point components is more than 25 Kelvin, then we use this technique, distillation. In this distillation technique, and this is used for the production of gasoline, distilled water, xylene, alcohol, paraffin. Here is an example. If you have a mixture of acetone and water, then how can we separate it? Have this distillation flask, thermometer is there for the boiling point or the temperature of the coffee. Then if a substance has less boiling point, then it starts boiling fast, and here in this case acetone has a less boiling point. It boils at a much more faster rate. So once it starts evaporating, then it converts into vapor form, and this vapor gets collected in this water condenser where it gets cooled down, and then it gets collected in this beaker. Water is kept. Now question comes based on these topics. Is the two conditions essential for using distillation as a method of separation of the components from the mixture? As I told you, distillation can be done in those solutions which are miscible with each other. It means they can mix together, and if these components have a boiling point more than 25 degrees, then only we use this distillation. Now next is fractional distillation. Fractional, it means in fraction. In small fractions they are segregating or separating, and here less than 25 degrees Celsius boiling point if we want to separate the boiling point. Now in this technique, what we need to do is, suppose here we have taken a mixture of ethanol, and when we provide heat, here fractional column is there. Fractional column means here at different fractions the components gets collected depending upon their boiling point. Now and thermometer also we use it. If we mix them together again, similarly the same process with the distillation, but the difference is here in distillation the boiling point, the difference in the boiling point more than 25, and here less than 20, and this the more the substance which has less boiling point, it starts evaporating fast and it gets collected in the fractional column. Then again the next fractional column, then it gets collected in the condenser. Here again it cools down and collected. So here if we have taken a mixture of ethanol and water, so ethanol has less boiling point, so it goes up first and gets collected in this flask, and this is known as distillate. Now there are two differences. The question comes on the basis of the differences. Two differences between simple distillation and fractional distillation, and the answer is simple distillation is used if they have boiling point difference in the boiling point more than 25 degrees, and if the difference the boiling point is less than 25 degrees, then we use fractional distillation, and we use for this fractional distillation in petroleum also. Petroleum is a mixture of different components. Next question comes on the basis of fractional distillation. We draw a well-labeled diagram showing the process of fractional distillation for this diagram with labeling. the 3-mark question. Sometimes they'll ask for the explanation as. Next method is crystallization. Crystallization is a technique in which solids are separated from solution. And as I told you, we use salt and water. So solid and water can also be separated by evaporation. But in evaporation, some amount of moisture is still present in. So if we want the purest form of this substance, the purest form of crystals of salt, we use this crystallization method. And for this separation of alum crystals, we use crystallization. Another example is if we want crystals of copper sulfate, we use this crystallization technique. And in this, we heat the solution and then we get the water content which is present in it, it evaporates completely, leaving behind. The question comes on the basis of this crystallization is, crystallization is a better technique than evaporation. Give reason to justify this statement. And the answer for this kind of question is, when we are doing this evaporation, some solids can also be decomposed. Like if we are taking example of sugar and water, some sugar can decompose, and then due to direct heat, because in evaporation we provide direct heat, but in crystallization, as you see in this diagram, we are not providing direct heat. On beaker we kept this watch glass, so that is the reason the solute cannot decompose. And if some minute impurities or particles may still be present in the solution, they can be easily removed by the filtration, crystallization, and we always get the purest substance. And in evaporation, we do not get the purest form of the crystal. Now, what type of other questions asked from this topic? That is, which separation techniques you will apply for the separation of the following mixture? And what are those mixtures? First is oil from water, camphor from sand, sodium chloride from its solution in water, cream from milk, metal pieces from engine oil of car. Now, first is oil from water, because oil and water, they are immiscible solutions. Use separating funnel. Camphor from sand, camphor directly is in liquid without going through liquid phase. For this mixture, we use sublimation. Sodium chloride from its solution in water, we use crystallization. We want pure crystals of sodium chloride, that is salt. Cream from milk, use centrifugation or centrifugal machine, and the method is centrifugation. Then metal pieces from engine oil of a car by using simple filtration technique. Oil can easily come in the beaker and metals left behind in the funnel, being large size particles, metals can not pass through the funnel. Then fractional distillation we also use to obtain the different components which are present in the gases. As we know that air is a mixture of certain gases and we call it a homogeneous mixture. So, if we want to obtain the different gases which are present in air, we use this fractional distillation. For this method, we need this air under this pressure. When we pass the air under pressure, then different components which are present in air. These components are nitrogen, oxygen, carbon dioxide, argon, and other substances. They get separated out depending upon their boiling point. And these boiling point, whatever the gas has, it comes first. And when they come out in this separator, separator one, it comes out first, the form of dry ice. Then other gases evaporated and gets collected here. They form the separate layer. Then nitrogen gas come out, then argon, and the liquid hydrogen gas. So in this technique, the fractional distillation is important to separate different gases which are present in air. Then this is the table in which what type of mixtures are present and what techniques. It is the summary of the different type of the mixtures and their separation technique. If two immiscible liquids are present, separating. If ammonium chloride or sand is present, to sublimate. Dyes in black ink, chromatography method. And if two miscible liquids are present, and if solid particles are present, use. Now, how can we get the purification of water? How we do process? Let's study here, because water contains lots of impurities, and first we purify that water, then only that water becomes fit for the consumption. So first we collect the water in a reservoir and then in a sedimentation tank. By the process of sedimentation, particles being heavier in weight, they settle at the bottom in this sedimentation tank. Then these sedimentation tank impurities are settled at the bottom, and then water is rest of the liquid substance transported to loading tank, where the suspended particles are present and they keep floating. Then in this, after this loading tank, then it is transported to filtration tank, which has 3 layers. Fine sand layer, then gravel and filtration this tank. Now first, second and third layer. After passing the layers, impurities are settled at the bottom when they passes these layers, and then the pure form comes here. But still it has some germs present in it. Passes to chlorination tank, where bacteria or the germs present in, they can be killed by chlorine, because chlorine acts like this in, and then we get chlorous form, which finally consumed. We use chlorine in swimming pools also for the purification, so that if germs are present in that water, that can be discarded. I hope you like the session.